So just, a little FYI. A lot of your trig is just about remembering rules and knowing how to apply them. So sorry about the spam that's happened and that we're about to go through, because it is pretty much just about remembering rules and knowing when and where to substitute things in. So we've been over sine, cos, and tan. Just another thing to sort of note, tan can also be expressed as sine over cos. And the reason that this is important is because it comes into play when we are looking at our reciprocal trig functions. Okay, so we've got cosec theta equals 1 over sine theta, so that's the hypotenuse of the opposite. Sec theta is 1 on cos theta, so the hypotenuse of the adjacent. And cot theta is equal to 1 on tan theta, which is equal to the opposite of the adjacent, which can also be written as the reciprocal of the tan we just looked at. So cot theta can also be written as cos theta over sine theta. So these are all your reciprocal trig functions. So pretty much you find them by just, flipping your normal trigonometric functions around. They are actually also written on your formula sheet, I'm pretty sure, so you don't even really have to remember them. So just knowing that they exist, that they're there, and when you see them in questions, recognizing that cosec is the reciprocal of sine, sec is the reciprocal of cos, and cot is the reciprocal of tan. It's pretty much all you need to be able to remember. And then from there, if you know that cosec is the reciprocal of sine, you know it's going to be hypotenuse over the opposite, and then the same for each of the following ones. Something else to know with trig is about trig identities. So looking at how to prove cos squared theta equals sine squared theta equals 1 is actually one of your syllabus points. I'm going to say it's going to be pretty unlikely that you're going to be asked to actually prove this. I've never personally seen it in a question, but it is in the syllabus, so you do need to know it. And then from that equation, you can then derive the second of the trig identities, that 1 plus tan squared equals sec squared theta, and 1 plus cot squared theta equals cosec squared theta. Now, this identity here is on your formula sheet. These two are not, so you do have to know them. And they are super, super, super important to know for when you get questions about trig identities. So we'll have a look at some of those example questions in a little bit, but just knowing that they're there for now is enough. So to prove it, our sine theta is equal to the opposite of the hypotenuse. So if we rearrange that, we can say our opposite side is equal to the hypotenuse times sine theta. Then if we've got cos theta, we're going to have the adjacent over the hypotenuse. So we can therefore say that the adjacent is equal to h cos theta, so the hypotenuse times cos theta. If we then use Pythagoras to do a squared plus o squared, so adjacent squared plus opposite squared equals hypotenuse squared, we'll get h cos theta squared plus h sine theta squared equals h squared theta, which you end up with h squared times cos squared theta plus h squared times sine squared theta equals h squared. Divide all of those things by h squared, and you end up with your cos squared theta plus sine squared theta equals 1. So like I said, I think it's unlikely that you'd actually ever get asked to do this, but it's not too tricky of a proof to understand. So it is worthwhile knowing, and I think it also does help you just with a general understanding of what's going on. So let's have a look at some practice questions. So I think trig identities questions are probably the hardest part of Year 11, both trig and maths in general. So let's have a look at this question, which says sec squared x plus sec x tan x equals 1 plus sine x on cos squared x. So we're being asked to prove this question. So how can we prove that the left-hand side is equal to the right-hand side? So you guys may not have seen trig identities questions before, so I'm just going to go through this first one with you. So essentially, in order to do this, all you need to do is prove that the left-hand side is equal to the right-hand side of your equation by just manipulating things in between. So the left-hand side is equal to sec squared x plus sec x tan x. And so that's like literally what the left-hand side is equal to. We haven't changed anything there. So then sec squared x is the same thing as writing 1 on cos squared x, because that sec squared x is just the reciprocal of the cos. Then we can write sec x as 1 on cos x, and then multiplied by tan x, so this dot represents a multiplication, and then tan x is just sin x on cos x. So then once we do all of that, when we multiply these together, we would get sin x over cos squared x. So if we've got 1 on cos squared x plus sin x on cos squared x, add those two fractions together, we get 1 plus sin x all over cos squared x, which is equal to the right-hand side. And so that's all we need to do to prove that equation. So you guys have a go at these ones. So let's maybe give you guys a minute or so, have a go at part A, and then part B is tricky, so we might do part B together. So if you guys have a go at proving that sec squared theta minus tan squared theta equals cosec squared theta minus cot squared theta. Honestly, these are really hard, but they just rely on the fact that you know about your trig identities and what your reciprocal trig values are equal to and things like that. So have a go, remembering that you've just learnt this stuff, so if you can't do it or you're a bit confused, don't worry about that, because honestly you've just learnt it and you have so much time to perfect it. Okay, so let's have a look at these ones. If we've got sec squared theta minus tan squared theta equals cosec squared theta minus cot squared theta, let's first look at our left-hand side, and we've got sec squared theta minus tan squared theta. And then if we use the identity that 1 plus tan squared theta is equal to sec squared theta, so we just substitute 1 plus tan squared theta here, we'll end up with the fact that the left-hand side is equal to 1. Okay, from there, let's look at the right-hand side. So if we've got cosec squared theta minus cot squared theta, let's use the identity 1 plus cosec squared theta equals cot squared theta. Just pop this into our equation here, and we'll get the right-hand side also equal to 1. So therefore, left-hand side is equal to right-hand side, and we've just proved that identity there. So that's why it's really important that you know these identities, because they're not on your formula sheet. They are unfortunately just something that you do have to memorize. And so I'll go through part B as well. So if we've got 1 plus cot theta over cosec theta minus cos theta equals sec theta over tan theta plus cot theta, let's start by looking at the left-hand side. So we've got 1 plus cot theta over cosec theta minus cos theta. Then let's think about the fact that cot can also be written as cos theta over sin theta. Substitute that in and we'll get 1 plus cos theta over sin theta. Then think about cosec can also be written as 1 over sin theta, and then we don't change that cos theta. If you're ever stuck on these questions and you do have reciprocal trig values, just try putting in their sine, cos and tan values, and you'll usually get a bit of an indicator as to where you need to go. Then once we expand all of that, we'll get 1 plus cos theta over sin theta times sin theta minus cos theta. Multiply these brackets by the sin theta, and we'll end up with sin theta plus cos theta minus cos theta equals sin theta. Okay, so the left-hand side is equal to sin theta. Then our right-hand side, we've got sec theta over tan theta plus cot theta. So we can also write sec as 1 on cos theta. We can also write tan as sin theta on cos theta. We can also write cot as cos theta on sin theta. Then moving these and making this denominator just into one fraction, we'll get sine squared theta plus cos squared theta over sine theta cos theta. Then we'll get 1 on cos theta multiplied by sine theta on cos theta on 1. Essentially because in order to get rid of this fraction in the denominator, what we do is we flip it and we multiply it by the numerator. And then we get 1 here because sine squared theta plus cos squared theta equals 1, because we know that we just proved that identity. So that was the identity that we proved just here. So we'll end up with 1 on cos theta times sine theta cos theta on 1 equals sine theta. So therefore the right hand side equals sine theta and the left hand side is equal to the right hand side. And then that is all we need to do for that. Now that last trig proof was actually really hard. So if you're a little bit confused by it all, don't stress because it was really hard. And you have a lot of time to learn these as well. So what I'd recommend is that after you do trig identities in class, or when you feel a little bit more confident with them, come back to this lecture, come back to the slides, have a go proving those identities again, and you'll have to see like how much you've grown as well in maths so far.